Hello students, welcome to online maths classroom. This is part 3 of your continuity and differentiability, and in this video we'll solve exercise 5.1 question number 14 to question number 21. So let us start with it. Question number 14 of your NCERT exercise. Discuss the continuity of the function f is defined by, this is 3 when x is lying between 0 and 1, 4 when x is between 1 and 3, and this equal to sign means at this values of x equal to 0 or equal to 1, the same defining is there, and when x is between 3 and 10 at 5, the value is given. Okay, so where should I check the continuity? I have to check, as I have to discuss, I have to check everywhere. So between this, okay, at 1 because it is LHL and RHL are defined at 1 to 3, okay, at x equal to 3 at is again differently defined, and for between 3 and 10. Okay, I don't need to go for x greater than 10 as the function is not required there. Okay, so first case is between 0 and 1. So between 0 and 1 it is 3, a constant function, continuous. Okay, at 1 it is defined in different ways, so LHL and RHL and f of 1 will be used. So LHL is your simply whatsoever value you put x as 1 minus h even, and here you will put x as 1 plus h, even as the function is defined as constant 3, so there is no x to replace this value, so simply it is 3, and for the right one it is 4. As both are not equal, function is not continuous at x equal to. Between 1 and 3, function is your 4, constant is continuous. At x equal to 3, I have to go for again LHL and RHL. Okay, same way, put x as 3 minus h, put x as 3 plus h for left and right hand limit. So this value, as there are no x there where you have to put these values, so x is 4, LHL is the having value 4, RHL is 5, which are not equal, so function is not continuous. Between 3 and 10, it is again 5, a constant one, so is continuous everywhere. So 1 and 3 are both the points of discontinuity, and f is behaving continuous for all real numbers excluding 1 and 3. This is how do we write it as. Number 15 says, discuss the continuity of this function, 2x for x less than 0, 0 for x between 0 and 1, and x greater than 1 it is 4x. So where should I check? Less than 0, at 1, between 0 and 1, and greater than 1. Okay, as function is required for greater than 1 also. So for less than 0 it is 2x, this polynomial, and is continuous. At x0 I have to go by LHL and RHL. Okay, so again it is, say I'll put 0 minus h, so the value is putting here 2 minus h, that is it becomes 0. RHL also becomes as 0. Okay, it turns out to be 0, so both are equal, and f of 0 is again also 0. So function is continuous at x equal to 0. Between 0 and 1, fx is 0, a constant one, and is again continuous. At x equal to 1, I have to check again the left limit and right limit all the way. So put x as 1 minus h for left, 1 plus h for right. This limit turns out to be 0, this one as 4. So both not equal, function not continuous. For x greater than 1, it's again a polynomial 4x, so which is continuous. So again the discontinuity point is just 1, so we write it as f is continuous at x belonging to R minus singleton set 1. Question number 16 of your NCERT says, fx is your minus 2 for x less than equal to minus 1, 2x for minus 1 and 1, and 2 for x greater than 1. Okay, between minus 1 and 1 it is 2x. So where should we check the continuity? For x less than minus 1, at x minus 1, as both definings are there, between minus 1 and 1, for x equal to 1 and x greater than 1. So let us start. For x less than minus 1, it is minus 2, a constant function which is continuous. Okay, at x equal to minus 1, I have to check both LHL and RHL. So LHL is simply, as if I don't go for minus 1, putting x as minus 1 minus h, that way also, because it is constant function and the value will be minus 2. Okay, for the right hand limit it is 2x, so I can go for x as minus 1 plus h also, or simply also, because this is a very simple this calculation, so it is minus 2 itself, and f of minus 2 is again minus 2. So LHL, RHL both are equal, and the value of the function, that is minus 2, is also equal. F of minus 2 is also equal, so function is continuous at x equal to minus. and x equal to 1, again I have to check LHL, RHL and f of 1. Okay, so for your left hand limit, your function is 2x. Simply I can go for 1 minus h also, but that way we also get the value as 2. And for RHL again it's a constant one, so simply it is just 2. And f of 1 is also your 2. So we get LHL, RHL both are equal and the value of the function at 1 is also equal. So function is behaving continuous at 1. Moreover, for x less than minus 1, it is function is minus 2, which is constant, so continuous. Okay. For x greater than 1, it is 2, which is again a constant function, so continuous for all real numbers. Okay. And for the case number 5 means between minus 1 and 1, again it is 2x, which is a polynomial. So this function is also behaving continuous. Okay. So overall for this question number 16, we find that fx is continuous for all real numbers. Okay. Okay, so function is behaving continuous for all x belonging to R. Number 17. Find the relationship between a and b so that function defined by this is continuous at 3. Ax plus 1 when x less than equal to 3, bx plus 3 when x is greater than 3. Okay, as it is given, I have not discussed the continuity. So as the function is behaving continuous at x equal to 3, that means LHL at 3, RHL at 3 and f of 3 all are equal. So I just evaluate the limits. Okay. Simply this one by putting x as 3 minus h. So that h approaches to 0, f of 3 minus h. I'll put it here. A times 3 minus h plus 1 and it will turn out as 3a plus 1. For right hand limit, I'll put 3 plus h here. So b of 3 plus h plus 3 turns out to be b plus 3. And f of 3, I'll get it from here. It will be 3a plus 1 again. All set equal from this and I'll get the equation as 3a plus 1 is 3b plus 3. And by simply solving, I'll get a is equal to b plus 2 by 3. So this is the relationship that for which the relationship between a and b for which the function is behaving continuous at x equal to 3. Question number 18. Question number 18 is for what value of lambda is the function defined by fx is equal to lambda times x square minus 2x if x is less than equal to 0, 4x plus 1 if x is greater than 0 is continuous at x equal to 0, and you have to check the continuity at x equal to 1 also. Now you know at x equal to 0 I have to check the LHL limit, RHL limit and f of 0. All of them should be equal, then only we can say something about the continuity of this function. Apart from it, in this question it is required that you have to check that value of lambda for which the function is behaving continuous at 0 also and 1 also. So please observe this question carefully. Again, you know I have to go by left hand limit and right hand limit. And for left hand limit it is defined as lambda times x square minus 2x. For RHL it is defined as 4x plus 1. Okay. So for LHL I'll put x as 0 minus h so that as x approaches to 0 from negative side, h will approach to 0. It is f of minus h. Put it here. Lambda times say minus h square minus 2 times 0 minus h. So it is lambda times, when I'll put the limit, lambda times it is 0 plus 2 times 0 and it turns out to be 0. Now see here, only this term was having lambda. Now lambda has no contribution. As you see, whatever you will put inside, this term is going to be vanished because of this h. Okay, because it is lambda times something. And this result you can check for other values also. Okay, for this particular 0, you will see that this lambda is getting vanished. Okay, again for right hand limit at 0, what do you see? That what we see is that limit you have to put x as 0 plus h. Okay, so limit h approaches to 0, f of h, you put it here, it is 4h plus 1, again 4 into 0 plus 1. So one way is that LHL is not equal to RHL and function is not behaving continuous at x equal to 0. Okay, apart from it, he asks that whatever the value of lambda is there now, as the limits are not equal, also moreover lambda is getting vanished at 0 also. So this function for any value of lambda will be behaving discontinuous as the limits are not equal. Okay, for x equal to 1, say x equal to 1 means the value is just this one, the 4x plus 1. Okay, because whatever is greater than 0 is for x is also 1 is also greater than 0, so it has single defining 4x plus 1. So you can check it like for right hand limit and then f of 0. That way also it can be done, and moreover it's a linear polynomial and is continuous at x equal to 1. Okay, that means for any value of, because here there is no lambda, okay, no lambda, so wherever as lambda is not there, for any value of lambda this function will behave continuous. Now question number 19. Number 19 is your show that the function defined by gx is equal to x minus greatest integer function is discontinuous at all integral points, where this, it denotes the greatest integer less than or equal to x. Okay. Now first of all, let us understand or recapitulate what was your greatest integer function. Now you know that by putting the value in this greatest integer function, what will be the value of this integer function? For 3 it is 3. Okay, means you have to go for the left. Okay, like if 3.1 is between 3 and 4, so it will be to the left is 3, so it will be 3. 3.1 is 3. 3.999, again it is between 3 and 4, but to the left is 3. Again 2.999, it is between 2 and 3, but to the left is 2. Okay, so simply I should know that if it is, say, like your C plus H, okay, C plus H, okay, so it will be your C, means the back point. Again for the other one, okay, C at, this is the value, like C will, it will be C, or okay, for C plus H it will be C, and for the negative values, as you know, if say I say it is minus 2.1, so minus 2.1 is between minus 3 and minus 2, to the left it is minus 3. Okay, so minus 2.1 means minus 2 means 1 less than it, minus 2 minus 1, that is minus 3. So that's why for left hand limit we take it as C minus 1, and for right one it is at C. Okay, now I will go for this question as gx has two functions. Say it is this, say hx, and this one is your fx. Okay, and for C any integer I am checking the continuity of this function. So it is the difference, if it is the difference of two continuous function, then it will be continuous. Okay, now I know this identity function x is always continuous, so I'll go for checking of this integer function. Okay, again I'll go for LHL, RHL and G of C. Okay, so this function is your, put x approaches to C from negative side, put x as your C minus H. Okay, so altogether I am taking this as, you can go for like hx minus fx also, check the continuity of this, or altogether we can go for checking like this. Okay, so we are taking it as altogether this way. So it is put as g of C minus H is your C minus H in place of x, and it is minus times C minus H. Okay, so you know C minus H for left hand limit will be 1 less than the integer, that is C minus 1. Okay, open it, I'll get it as minus H plus 1, and the value is turning out to be as 1. For RHL, it is G of C plus H. So again it is C plus H minus C plus H. Now this will turn out to be C, and it is minus H and turns out to be 0. As LHL is not equal to RHL, so function is not continuous at x equal to C, and gx is not continuous at all integral points. Okay, so differently also go, and all together also, it is very simple. Number 20 say is the function defined by fx equal to x square minus sin x plus 5 is continuous at x equal to 5 pi. So again we need to check the continuity at x equal to pi. I check the left hand limit, right hand limit, okay, and limit x approaches to pi of fx equal to f of pi. If this is going to happen, then this function is continuous. This is your method number 1. This is your simple method number 2. Okay, so as the function is defined singly also, you can go for the right hand limit also. Okay, that way also. So it is your x square minus sin x plus 5. So it is pi square plus 5. Your this side is also turning out to be pi square plus 5. Okay, and f of c is also pi square plus 5. So function is continuous at x equal to pi. The other way is, this is your px is, break it in 3 functions. This is your quadratic one, is continuous. This is your trigonometric one, is continuous. Constant one is continuous. Okay, and by algebra of continuous function, the sum of continuous functions with difference also, like this is the px minus, means the sum of these two and the difference of this one will also be a continuous function. Number 21 is, you discuss the continuity of the functions sin x plus cos x, sin x minus cos x, sin x into cos x. So again, you know that break it as 2 function. Okay, here also, here also. Now Since sin x and cos x are both continuous, so by algebra of continuous functions, the sum of two continuous functions, the difference of two continuous functions, and the product of two continuous functions is always continuous for all real numbers. So this is a simple case. So this is all regarding your question number up to 21. The rest we will solve in the next video.